The broadcast is now starting. All attendees are in listen-only mode.
Good morning to everybody. My name is Peter Sotner. I'm working in Sub10 Systems as technical support. We are almost ready to start our today presentation. Before it, I would like just ask you to somebody confirm me that the voice or sound coming from me, it's okay. Can somebody just put question or hands up to confirm me that the voice, it's okay? Okay, I see some hands ups. I expect that everything is okay. There is also some question that it's okay. Thanks for it. Okay, again, my name is Peter Sotner. You see my contact, and our today training, it's related to V and E-band installation. It's the installation, it's meaning in very generic view, because we found during our meeting with customer and our partners that sometimes some basic information are missing, and this is main goal of this webinar, to provide you really key informations which are really necessary for link installation, for link planning, and also for link testing in lab. Our agenda is very briefly introduction. I almost finish. I will just concentrate on some key terms and key points really important for understanding of the rest of our presentation. The next part, very important, will be related to our Sub10 tool, which is used for link calculation or link budget calculation. And then a couple of slides related to basic link configuration. If you are receiving link, what is coming in, what is the basic step which you need to do before testing. And then we will focus on testing in lab, which is not so easy for some products because, you know, it's microwave system. There is always expectation that there will be some pass between these two terminals, and if you are testing in lab, you are limited by distances, and you have to make some special attenuation to be sure that link will work. At least you will be able to test configuration and some customer settings and so on. Next part, it's related to terminal installation. It's mainly for physical terminal installation, I mean on site. I will highlight some key points which are really necessary to have proper installation which will work for a long time. A couple of slides related to link alignments, and some also I will present some tools which can help you during the alignment. And last session will be related to typical installation mistakes because we have a lot of installed links and we are visiting our customers or our installation time to time, and if there is something which is not so good example, we have photos of it, and I will share these photos with you. And at the end there will be overview of resources where you can find some more information. We have a lot of videos on YouTube, and you can see some specific topics like seal kit installation, E1000 alignment, and so on. Regarding introduction, we are saying that we are working in millimeter waves, or you can see abbreviation MMW. And just very briefly, what is it? Millimeter waves mean it's an electromagnetic radiation which is using wavelengths between 10 millimeters and 1 millimeter. If you use the formulas and put or calculate the frequency range, it's from 30 gigahertz. In 30 gigahertz you have a wavelength 10 millimeters, and finishing at 300 gigahertz, which is 1 millimeter. The edge or border between traditional microwave system and millimeter waves, it's not so precise, because, you know, currently we have a microwave system running at 38 gigahertz. What is key? It's really high frequencies system or signal, typically starting from 60 gigahertz high. You can also see another abbreviation which is called extremely high frequency. and it's same. It's again related to MMW, which is, I think, almost standard. Everybody is saying millimeter waves, and it is what I mentioned, from 60 up. Characteristic, if you are looking for millimeter wave systems, what is the typical for these systems? First one, it's designed for point-to-point application. You have two terminals or two locations, and you need interconnection between these. It's for short range. It's starting hundreds of meters or tens of meters, going to up to 6-7 kilometers. But you have to be careful, because the high frequency means higher attenuation or high attenuation coming from the rain. And if we are speaking about 7 kilometers, it's in area where is almost no rain. If you are looking for area where it's raining, like for example Europe, when we have average rain level around 40 millimeters per hour, we are going to the lower distances, typically less than 3 kilometers. What is good for end customer is that in many countries it's a very cheap band. It's license exempt, that you are paying nothing, or it's lightly licensed, that you are paying some registration fee, that your link is running, and it's all. Regarding the physics or signal propagation, characteristic is that antenna beam, it's very narrow. We are speaking about, for example, in band, which I will mention later, E-band, we are speaking about antenna beam 0.5 degrees. And it's logical that it's perfect for reusage of frequencies, because you have very narrow antenna beams, and you can put links or reuse the frequency, same frequency, in close locations. And also you have very nice condition for collocation if you need to concentrate more links in one physical location. Because of this narrow beam, you have also, how to say, hidden security, because it's not so easy to sniff signal. If you look for 5 gigahertz band, everybody can sniff signal with millimeter wave. It's not so easy, and plus the equipment for sniffing, it's really expensive. And it's small form factor, especially for V-band, as you can see later. It's a very compact device which can be installed even in windows or close to windows on buildings, and you can really easily make it hidden for people, which is really important, especially for city installation, that some local municipalities are asking, okay, you can install point-to-point link, but there will be no visibility, no antennas, and so on. And comparing to mainly laser technologies, these systems are not affected by fog, snow, or dust. Only rain has to be calculated during the link budget preparation. And now, to have some concrete numbers, if we are speaking about millimeter waves or millimeter systems, currently you can see two main bands or sub-bands. One is called V, as Victory, and it's around 60 gigahertz. On this slide, it's yellow part. And second one, it's E-band, as Echo, and this system, it's currently using in two windows. You can see something between 70 and 80 gigahertz, and something between 80 and 90. Physically, it's from 71 to 76, and from 81 to 86. There is 10 gigabit fixed duplex between lower and upper frequency band. And these are today used technology. If somebody is saying, I have V-band equipment, it means it's running around 60 gigahertz. If somebody is using E-band equipment, it's running 70/80 gigahertz signal. Characteristic, just to explain you what is really important, and this is also explanation why V-band links are shorter, much shorter than E-band. You see on this graph, it's again going back to the previous colors. If you look for the yellow column, it's a 60 gigahertz signal, which is V-band, and you see there is a very big absorption or attenuation coming from atmosphere. The oxygens or atmosphere is doing attenuation without any rain. Just if you have pure attenuation, the V-band has something between 12 to 15 dB per kilometer. If you look for E-band, it's much better, because this attenuation is going down, and we are speaking about 0.2 dB per kilometer. But if you look, this is just atmosphere without rain. If you have rain, it's opposite. V-band has lower attenuation than E-band for the rain, but you will see later on this calculation. But keep in mind, V-band, it's shorter, and reason is this oxygen absorption peak. But advantage is you can use a lot of V-band system in city for short links. We are speaking about, I don't know, 500 meters for full gigabit, and you can going up to 800-900 meters if you are looking for fast Ethernet. It means 100 gigabit. I didn't mention before, but all these systems, V-band, E-band, which are producing by Sub10 Systems, are working as FDD, frequency division duplex. It means you have all products. You have terminal A, which is transmitting on lower frequency and receiving higher frequency, and terminal B, which is opposite, transmitting on higher and receiving on lower. In this case, if we are speaking about gigabit or 100 megabit connection, it's always full duplex, that you have 100 or 1 gig from A to B and same capacity from B to A. If you are comparing, second option is TDD, which is time division duplex, when you are sharing one channel and systems are changing or sharing this frequency based on the time. And in this case, if I compare our system, which is gigabit FDD system, and you would like to compare is with TDD system, it's like 2 gigabit system, because in TDD, if somebody is saying frequency it's, or capacity, it's calculating downlink and uplink, which is typical for TDD system. But again, Sub10, it's producing just FDD system. If we are speaking about capacity, for example, 500 megs, which is also one product line, you have 500 megs between A and B, and same capacity between B and A in same time. Okay, now we are on our product lines. We have two lines based on the typical application, but you know, it's not so easy to say exact application. But on the left side, you see edge links. Edge, it's used for edge connection, that it's not typical core, but for some customer, this system can be used for core application as well. It's just our internal splitting. And in edge portfolio, we have two products which are coming in V-band in 60 gigahertz system, and starting from the top, it's V1000, and this number, as you expect, it's providing information about maximum capacity. Liberator V1000, it's full gigabit system. You can have 1 gigabit from A to B, 1 gigabit from B to A, and we have also commercial, how to say, lower system, that you, if gigabit it's too enough or too much for you, you can start with 500 megabit systems, which is like half of gig. What is good, that upgrade from 500 megs to full gig, it's just the software. You don't need to replace any component. You can simply upgrade to the software license. Second system in V-band product, it's V100, and as you expect, it's fast Ethernet or 100 megabits full duplex system, and again, same frequency, it's 660 gigahertz band, which is V-band, but you can go, if you need the highest link, this is exactly this system. We are saying up to 1000 meters. You will see later exact link length based on the availability and location later on, but this is a system which can provide you really fast Ethernet connection up to 1 kilometer. Next system in our edge part of the product, it's called Liberator E1000E. In this case, E really means edge, and it's same as V1000. It's full gigabit system. You can, if you need save some money during the start or initial installation, you can order it as 500 megabit system, and later on through the software upgrade it to full gig. And this system, it's a little bit different. It's coming with, I didn't mention, but V-band, it's using integrated antenna. This is the device which you see on the left. I am just now making circle around it, and this is V-band system. Antenna, it's integrated inside. V-band system, which is next to this one, It's using traditional microwave system that you have antenna, which is this part, and you have ODU unit, which is clip on the antenna. And based on the application for E-band, we have 30 centimeters antenna, which is on this picture, and we have also 60 centimeters antenna. Difference is that with 60 centimeters antenna, you can go for longer distances because antenna has higher gain. And in core, because sometimes you need a even longer connection than its base, which is possible through our E1000E system. We have system which is called E1000C. Difference is between E and C. It's mainly in maximum transmit power output. The E system, it's limiting to 6 dB. C system, it's limiting to 20 dB. And again, same approach. You have 30 and 60 centimeters antenna available. Okay, now more concrete, if we are speaking about link, what is behind the link to see all components, it's on this picture. In blue, it's V100 or V1000 system. In red, it's E1000E. And rest of the connection, it's same. If you are looking from the bottom, you have some LAN, or it can be even computer or some high definition camera. It's going to the PoE, and from PoE you are going to the terminal. If it's E-band, it's this system antenna plus ODU. If it's V-band, you have just integrated system or unit ODU with antenna. And same on the opposite side. One side, it's called terminal A. Opposite side, it's called terminal B. And it's all. If you you see that power is going through PoE, we are using PoE injector, which is classified as PoE++. We have to have something, depend on the product, but up to 40 watts power consumption on this link. And we are using this connection also for data. It means there is one cable going from PoE to unit, doesn't matter whether it's V100, V1000, E1000, and the data and power is delivered over this cable. This is really important for installation because this cable has to be at least Cat 5e, ready for gigabit, and it has to be outdoor version. It's really critical to use the outdoor version, otherwise you can be in trouble because after a couple of months the PVC jacket of the indoor cable can be damaged and water can go into the cable. You can have some mechanical damages on the cable and so on. But the link, it's looking very simple. You have terminal A, cable going to the PoE, and then from the PoE you are going to the some switch or device. Regarding the maximum distances, really important point because some people are not looking for documentation so deeply. But specification for gigabit Ethernet, it's 100 meters. You cannot create standard gigabit Ethernet longer connection than 100 meters. But now, if you are setting the link, keep in mind that PoE, it's not active data equipment. It's just power injector. It's passive equipment. And 100 meters can be from terminal to the PoE and also from terminal to the gigabit or to the switch. It means these two blue lines or these two blue connections, if you zoom length, you cannot go over 100 meters. Yeah? If you will say, okay, I will put 100 meters here and 50 meter here, it will not work. Keep in mind, the gigabit, it's 100 meter, and PoE, it's not gigabit device. It's just passing or adding power, and you have to calculate 100 meter from your switch or from device which is indoor going to the PoE, and then add the cable length from the PoE to the terminal. Okay, if you look for ordering procedure in our system, in Sub10 system, we are preferring to provide you everything as kit, that you don't need to take care of what to order, what is including, what is not included. And it's very simple. If you order V1000 link, you will receive everything in one box, and in this box you will have two terminals. One will be A, second will be B. These terminals are tested together in our production line, and we are sure that if when they are leaving factory, they are really working, and the radio parameters are as we declare in our documentation. Then you have two alignment brackets. You have 2 ice shield, which is this metal part which is putting on top of the unit. You have 2 times seal kit. You have 2 power injector. Based on specification, you have UK, US or European power cord, and you have 2 times mast bracket to be able to connect the unit to the mast. Plus this metal ring to be able to make connection. You have also box with screws to be able to connect everything together. It means this bracket with terminal and bracket with mast bracket. What is important and really keep in mind, the terminal, it's coming with currently cable which is 1 meter long. There is plan to put it a little bit longer, but very important, on the back part of the terminal, you will see later on picture, there is connection going to the unit, and this connection is tested by Sub10 to be waterproof. And now you can see also there is the tape protection, and on this tape it's if it's avoid, you are losing the warranty. Keep in mind, this is really checked to be sure that there is no way how water can go in, and all customer connection is done on this port using the seal kit. You will put seal kit on this port, on this RJ45 connector, and customer cable is going from the second hole of the seal kit. Remember, do not remove this cable which is going to the unit. If you remove it, first you are losing the warranty, but second you can physically damage the unit, because if water go in, it will definitely affect the circuit board which is inside. E1000, it's a little bit different. You have one box. When you will receive ODU, again, two pieces. One will be terminal A and second will be terminal B. 2 power injectors, 2 power cords, and also 2 seal kits. And then based on your link, on your application, whether it's, I don't know, 500 meters or 1.5 kilometer, you are ordering antennas, or you are selecting antenna. It can be either 2 30 centimeters antenna or 2 60 centimeters antenna. In this case, for example, for Europe, if I'm ordering some link for the Czech Republic, I will select link with Euro power cord, and then either 30 centimeters or 60 centimeters antenna. We have 2 parts which are applicable for my country, and based on my link length, I am selecting 30 or 60 centimeters. And again, it's very easy. 1 part number, and you are receiving everything to be able to install the link. And only what you need is the cable. If I go back, you will receive everything except cable which is going from the system to the PoE, and of course from PoE to some switch. In this case, you only need to have the outdoor Cat5e or Cat6, Cat7 cable. What are optional accessories available from us as standard? You can order optical scope, which is very useful for faster alignment, that you can use optical wave. Just look through the later on there will be picture, but you will look through the scope and you will see opposite side, and you can very easily find where is the antenna lobe, and then use DC voltmeter to finalize the alignment. This system, this scope, it's today available also for E-band if you are using 30 centimeters antenna and the system is using the vertical polarization. Next accessory is outdoor Ethernet cable. If you need it, you can order it from us, but usually you are able to find a good cable on good price locally. And last option is lightning protector. It's our high recommendation to protect system by a LPU kit, but it's your decision. Yeah? It's not necessary for technical functionality, but it's providing higher protection. Later on will be picture or scheme regarding recommended protecting on the link. If you would like to have the maximum protection, you have to use 2 LPUs unit on each side, because one, it's located close to the terminal, and second, it's located when cable is going to the building. In some countries, you can see rule that if any cable is going from outdoor to indoor, or it means from outside building inside the building, that you have to apply, or you have to install such protection. And in this case, if it's necessary by local regulatory, you can easily order it from us and put it and fulfill the requirements for installation. What is it was okay. What is coming, and it's just now under development and final testing, it's Universal Alignment Kit for E1000E. This kit you will be possible to put it on E1000 with 30 centimeters, but also with 60 centimeters antenna. And the alignment to look on the opposite side, we will use this scope, which is used by hunters. And advantage is that you have much higher focus, that you can really look. If you are using the optical scope for V-band, it's really designed to have good visibility up to 1 kilometer. But if you need to find your opposite end for, I don't know, 1.5 kilometers or 2 kilometers, it's not so easy with this basic 6x zoom, which is on V-band system. And this is why we introduced this one. First, to be able to use it on 60 centimeters antenna, and second, to have good visibility, to have good details, and to be able to find opposite end, which is okay if you are installing links where you are, for example, on some high building or some high chimney. But if you are positioning link which is on the roofs and you have a lot of roofs around, believe me, on 2 kilometers it's not so easy to find opposite end. Even for shorter distances, if you are in city, for example, downtown of Prague, you will not be able to find by eyes the unit which is 500 meters far from you. Okay, this is about introduction and brief introduction of our product line. Now we will look for link planning or link budget calculation. There is, how to say, nice picture just to present you what is key enemy for link. You see snow, fog, dust, it's not problem. We are not optical system, and snow, fog, dust, it's not blocking our. What is how to say, main factor for link calculation? It's rain, and you have to really calculate rain. It means the highest rain level which is typical for your region. The second one, it's you have to really carefully check, and I put this red rectangle, the line of sight. It's really important. Even if you have some temporary obstacles like this water tower which is affecting partially Fresnel zone or some crane, it's really important to check that there is nothing in the system or between the system. If you are going through the trees, it's not so easy to find whether trees or branches of the tree are affecting the Fresnel zone or not. But keep in mind, if you have any possibility that some obstacles like building, trees are close to your link, be careful that you have to double check that it's not affecting your system. And especially for trees, because you know they are growing, and if it's working 1 year, the next year can be a problem for you because some branch it's longer, more leaves, and during the rain it's providing attenuation, and your link will start with some errors, and later on even it will be dropped down. It's really important. The line of sight has to be checked, and it's more important if you compare with some lower frequency systems. And if you look for the formula, what you need to know, it's free space loss, but it's formula which is related which relate on the use frequency and distance. Oxygen absorption, it's partially gray. It's important for V-band because you have to check what is the absorption level for V-band. In E-band, it's not so critical, but the rain, it's again enemy, or has to be calculated for both V and E-band system. Now, if we are speaking about availability, it's typical to use some, how to say, generic terms or naming. You can see something like 4 nines. What does mean 4 nines? It means that I would like to have link available. It means link working 99.99% of year. If you calculate this percentage to real time, 4 nines mean that I am okay to have down or link outage for 53 minutes per year. And this is what is typical in microwave system. 4 nines. 5 nines, if you are speaking about 5 nines, it's more complicated because it's not just about the radio availability. You have also check what is the power, you have to have everything doubled and so on. But in radio system, you can typically see that customers are asking for 4 nines availability. sometimes they are able also accept 3 nines if they know that okay, it can be critical, but still it's like 9 hours per year link outage. Okay, if I now know that customer is asking for 4 nines availability, how I can check that my link will be 4 nines available? It's very easy. You have to find what is the rain level, and you see this dashed line on both pictures. It's saying that this rain level or rain is higher. It means it's above this dashed line only this 53 minutes per year. And you have 2 examples that it can happen that it was 3 times per year, but you see now if I count T1 plus T2 plus T3, I am 53 minutes or less. But next year it can happen that it's just in one period. And this is what you need to know. You have to, for each region, you have to find this dashed line, which is saying, okay, if, for example, for Prague, I know that 53 minutes per year, the rain level is higher than 42 millimeters. And this is number which I need to know. Okay, 42 millimeters per hour, it's rain which I have to be able to compensate by my system. To have idea what is behind, you see this link availability for some selected cities. For the UK, if you look for the London, and you are looking for 4 nines, the rain level is around 31 millimeters per hour. But if you look for Sub10 office, which is south from the London, or southwest, it's in area which is called Devon, you see that to be able to work 4 nines, to have just 53 minutes per year link outage, I have to calculate rain level about 46.4 millimeters. And you have another big differences. For example, if you look for the Spain, Madrid, which is in country, not so close to the seaside, you see it's 27, but if I'm looking for Barcelona, I am 48 or 47 millimeters. The next good example is, for example, Mexico. If I am in Mexico City, you see it's 58. But if I select some desert which is not so far from border between Mexico and US, you can find places where it's, for example, 33.5 millimeters per hour. And this is what you have to know. Don't worry, because our planning tool, it's calculated automatically. You just need to know coordinates where your link will be installed, and system is taking this data from ITU database. Okay, now we know what we have to find. If customer is asking for 4 nines availability, I have to find what is the rain level. But again, don't worry, if you use our link estimator, it's everything going in automatically. And there is summary before installation, what is really necessary to know, and it's very useful for you because you can avoid any future discussion that there was some assumption or expectation which are not possible or which we are not able to fulfill with our equipment. First one is you have to know where link will be installed. If you know where it's installed, okay, you don't need to know exact coordinates, I don't know 1 meter precisely, but you have to know the area, like which city it is, and you need to know the link length. There are different ways how you can calculate or obtain the link length. Easy for me all times. It's if customer knows where link will be installed, simply use Google Earth, because you are able to find buildings or place where mast will be located, and then you can, if you have these two places, you can easily calculate all other data which are necessary for calculation. You are able to calculate or to see on Google Earth link length, and you can also find altitude, which can help you, which is good to know also for calculation. The second one is check line of sight or line of sign. You can use some, how to say, binoculars, look with some scope to check if there is something between. You can partially use Google Earth, especially in cities. You can really quickly check if there is some high building or not. Before you start this installation, it's really check, but I know that it's not so easy time to time, but it's very good to know what is the mounting place, whether it will be on pole or on wall. if it's on the pole, what is the type of pole, what is the diameter, because if you are looking 60 centimeters antenna and you will put it on 40 millimeters mast, it will definitely not work because you will have a lot of vibration and you can have issue during the wind conditions. Lightning risk, to be sure whether it's really good to install the lightning protection or not. You have to be sure about power, if power is available on place where power injector will be located, because sometimes it's not in the server room, it's on some small box somewhere on the house, even on the top floor, and so on. And last option, grounding. It's really important to check the grounding, because you can see on some building big difference between ground which is on the roof and ground which is used by electricity. Just be sure that your mast is grounding. It will help you and it will minimize any risk that link is, for example, rebooting or it's not working as you expect because there is the big fluctuation on the power level. And also check how cables will be routed, that if it's a proper way how you can go with Ethernet cable from the terminal to the indoor place. And of course, before installation, make this link budget calculation to be sure that you know what values are okay for your link, and to be sure that your alignment is finished and you are on the best signal. Okay, I am the inputs for our link estimator or link planning tool. As I mentioned, the Google Earth is very easy because you can install it. You don't need any special functionality, just to know these two places, and then collect some data and then run link estimator. And I will show you just screenshot what I am doing if I need to make a link calculation. You see very easy. I am putting terminal A on the Google Earth because I know that there is location when terminal is located. I am writing down the coordinates, which is, for example, just you don't need to be so precise because you just need to know area for the rain. In this case, I will use 50.54 and minus 3.6. Then I will put second point, which is terminal B location. At this moment, I don't need to make the coordinates, but you can record. But important is that then you can create link between this terminal A and terminal B. And if you click on the link, you will see that the distance is 1.17 kilometer. This is what you know from the Google Earth, and you can also go and open the profile of your link, and you will see immediately what is the altitude, which is useful for some cities. For example, Mexico City, it's more than 2,000 meters above sea, and if you are doing calculation, it's important to put this value to the calculator. You see now that altitude, it's like something around 30 meters, and you have all what you need. I will just now move. You will have this in presentation, but I will select select the Excel sheet, which is you can download it from our support web or from our official web. And you see very easy tool which provides you a lot of information. First one, you can put some naming. I put training Prague, but okay, I can put Newton about. Then you can select what will be format of your coordinates, but I'm using degrees as decimal. I will put 50.54. The second coordinate it's minus 3.6. I know that altitude it's 30, and now I know that link was 1.170. These are inputs which you have to know before planning. The next one it's antenna orientation or polarization. If you are doing calculation for V band, we are using this slant. It's like that, it's square but which is putting on the corner, and in this case you will select slant. If you are making calculation for E band, which is using regular parabolic antenna, you can either use vertical or horizontal polarization. Because this is long link, I am doing E band calculation. I will select vertical, and here you have calculation for all our product. products. I didn't mention some first generation product like V320 or V1000 extended range, but you see V100, V1000, E1000C, E1000E, and you have different modulation. This modulation, it's providing you information what will be maximum capacity. For example, if I select Liberator V1000 and QPSK modulation, the error rate, maximum error rate or maximum user data which I can send over this modulation, it's limited to 700 megabits. If I'm looking for 1 gigabit, I have to use the APSK modulation, and in this case you are limiting to some shorter distances, which is logical. Higher modulation, it's more sensitive. You have not so the receiver sensitivity, it's higher or no lower. It's not so good as for the lower modulation. It's logical. Higher modulation, you have to have more energy, and usually higher modulation means shorter link. Pardon. What is good for our system that very soon we will have a load which is providing automatic modulation or adaptive modulation, and in this case you can design link that it will work on gigabit, but you will, for example, reach, I can put, I don't know, 600 meters or 500 meters, and you have such configuration. You see that V1000 in QPSK, it's 4 nines, even more, it's 495 available, and APSK, which is 1 gigabit, it's 398. And now you can easily prove to the customer this calculation. Okay, look, system, it's adaptive, it's capable to use adaptive modulation. This time per year system will work with gigabit, and if it's not gigabit, you have still able to have link which will be limited to 700 megabits only, which is 300 megabits less, but you have much higher availability. And this is very important if you are doing the calculation that if people are looking strictly for gigabit, just check, okay, but your distance is 600 meters, which is not doable to have 4 nines, but we can design the link that it will work 3 nines in gigabit, and rest of the time will work with 700 megabits only. But back to our example, I use this one, and you see in Liberator E1000E, I have on 30 centimeters antenna and QPSK, you see here, this is this line. So I have 4 nines availability. If I'm looking 30 centimeters antenna, I have just 3 nines availability. This is just overall what is important, that for each modulation and each system, you have here exact calculation. And now, if I am looking for my E-band calculation, and I am looking, for example, for QPSK, you have such screen when you have calculation for this modulation, QPSK, which is providing 700 megabits, and you can either use 30 centimeters or 60 centimeters antenna. And you have all these inputs data like 1.17 kilometers link, and at the end you have the availability. You have availability for vertical polarization, you have availability for horizontal polarization, and also you have expected RSSI, and this RSSI is also presenting as voltage, DC voltage, which you can measure for alignment. This lower part it's really important for installation team, because they know, okay, we have to receive this receiving level of the signal, and because they are not using computer and checking what is on the web GUI, what is the level of the signal, they know, okay, if I connect voltmeter to DC port, I have to reach something like 2.6 volt to have proper alignment. In this calculation, if you run this calculation and then install the link, typically you will see much better value than -44. For example, you will see -42, -43, or -40. And this is related that in this calculation, it's put some margin, which is 3 or 6 dB based on the modulation and product, to provide the calculation for long term or life term It means that now it's working, but you have 6 dB margin or 3 dB margin, and you are sure that after 5 years, when the receiver will be not so good and transmitter will be a little bit lower, the link will still work. Don't worry if you see better value. You are, how to say, good guy, because you have more for budget. But critical is check it if you calculate this value, and your real value has to be in some range, which is typical plus minus 3-5 dB. If I will make such link and I will have something like, I don't know, minus 52 as the best signal, I have to check what is the wrong. It can be either some obstacles, or it can be some dirty on waveguides, anything. But keep in mind, this calculation, it's, how to say, including some margin to provide link availability for lifetime, and you have to be in some range around this value, and you have to check if this range, if you are totally out of range, like this 3-5 dB, better or worse, you have to investigate why it's the signal so different. And of course you can print this system and make PDF page from it, and you can edit as part of your offer to have proof. Okay, based on information which I have, our calculation is on this level. What is good, because if you are working with some radio planning tool and you have some more data, you can see here, I didn't mention this section before, but you have here what parameters will be used for calculation. You see now, okay, my rain parameter for the Eschhaus or Newton Abbot, it's 46.4 millimeters per hour. And absorption, which is rated for V-band, it's on this level. If you know that this rain level is totally out of reality, that you know, okay, my rain will be not stronger than 38, you can simply put 38, and then from this menu you can select manual entry. And you see system recalculated the availability based on these parameters. This is really for people who are working with some radio design and they have much better data than ITU, because this rain data are coming from some ITU database, and again, this is something like assumption. We cannot guarantee that this year will not be stronger rain for more than 53 minutes, because there is no way how to know what will be in 1 year rain level. Good example is last week in South Moravia. For Czech Republic, you have typically 40 to 43 millimeters rain per hour to have 4 nights availability. But last week in some small area in Moravia, there was rain 80 millimeters per hour, which was for, I don't know, almost 1 hour. Yeah? And in this case, you are totally out of your calculation, because there was so strong rain in short time, which was totally unexpected. And again, this rain data are coming from some ITU database, and this is again calculation. It's not like it will be on this way, because there is no way how to know the rain level. But we have to have something, and this is the best one, which is used for long time, not only by us, but it's typical in radio systems, that you are using this ITU data to find what is the expected rain level which you have to compensate. Okay, I will return back to the presentation. Okay, I hope that you have back this screenshot from Excel sheet. What I present, you put values, and then you have the calculation what will be link availability. And again, you can go to the sheet like this one, E1000 EQPSK, and you will see the availability. And again, for installation, you will see that this DC equivalent to RSSI. Okay. Now we are ready for installation, because we know coordinates, we know link availability. Based on the calculation in our tool, you will know what polarization you will use, and you also know what DC voltage on alignment port has to be reached to be sure that your alignment is proper. Back to this availability, I make this calculation for some selected cities using our tool, and you have all products, and you have to just to present how important it's really done this calculation. Yeah. Look for it. We have two places in the UK, London and Sub10 office, and you see what is the difference. For example, if I'm looking for V-band and full gigabit, which is this 100 MPSK, this is this column. In London, I can go for 510 meters, but in Edge House, to have same availability, I am limited to only 470. It's 40 meters difference. And if you look, for example, for E-band, it's even more. It's 300 meters, almost 300 meters. If I'm looking, for example, for QPSK modulation and 30 centimeters antenna. This is one example, yeah? And the difference, why is it, is because you see difference between rain level which you have to compensate. The next example is if I look Sub10 office and Mexico. You see the Mexico has much higher rain level, it's 58.1 millimeters, but compared to the Edge House, but link it's almost same, which is something what is not so correct probably. But it's correct on V-band because the next difference is if you look for the average altitude in Mexico, it's about 2000 kilometers, and look the attenuation coming from oxygen absorption, it's not 15.3, it's just 12.4, and we have 3 dB on kilometers just because of different altitude. And this is just presenting you, if you are doing calculation, collect all these data. Where you are, it has to be just, I don't know, middle of the city, what is the link length, and then what is altitude, because especially in Europe, for example, in some areas we have mountains when you can have installing 1,000, even 2,000 meters above sea level, and it's totally different compare the normal countryside, which is typically, I don't know, 100, 200 meters. And you can, if you need very briefly such table, you can select in your country some typical places. Look, for example, in Austria, if I compare Vienna and Linz, okay, there is some difference between rain, but you can make a very roughly calculation for example, Linz, and you will see what is typical link length in non-country, non-mountains area. It means not in Alps region, what can be maximum link length. But it's really, how to say, something like recommendation or very quickly orientation. For any link, I prefer please go to the link planner because it's not so complicated. If you will know link length and place where it's located, you can very easily calculate what will be real availability and what is maximum distance of this link. Okay, we finished the link calculation. Remember, you can download this tool, it's free. It's very easy how to have input data using Google Earth, and you can everything, and it's just like 2-3 minutes, and you can verify that your link will work and what will be availability. And it's really important to know it because you can describe to customer what is the risk. If you plan link for 600 meters, you can expect that there will be some outage. And you can also know what data or what level has to be reached during the alignment to be sure that your link is aligned properly. Basic link configuration. All our terminals are coming with defaults. If it's coming from factory, terminal A, doesn't matter whether it's E or V band, has this address 192.168.0.21. The mask it's 24, it means 255.255.255.0. Terminal B, its next address, it's 22 at the end. Default login, it's admin and password. There is no VLAN settings, no VLAN for management, and Ethernet port on this system, it's auto sensing, supporting 10, or Ethernet, fast Ethernet, and gigabit Ethernet. If you need access to the device, it's very easy. If you power up the device and you program or configure address on your computer, which will be in same range, for example, 192.168.0.111 and 24-bit mask, then you can open the browser, put 192.168.0.21 as URL, and system will log you to the device. This is exactly what you see now. This is the screens. What is good, if you know any of our products, the screen or how to say, web it's same for V100, V1000 and E1000E. All these three products are using same web interface. E1000C, it's a little bit different. There is special application for controlling, and some previous platforms like V320, it's using web interface as well, but the look it's different. And same for V1000. Keep in mind, it's happening now time to time that people are using V1000, but you have to check whether you have old platform or new platform. V1000 new platform has this web interface. You see Sub10 logo and big red line. If web interface it's more gray, it's old platform or V1000, and you have to find typically it's issue with firmware upgrades, that you have to look what platform you have, whether old one or new one, and then select the right version. The easy it's also with numbering. Old platform it's using 1 dot something, just two numbers. New platform it's using 4 digits. It's like 2.1.1. something. This is very easy if you know what is firmware version. If it's short, it's old platform. It's longer sequence or more digits together, it's a new platform. Login, it's very easy. You see now I put 192.168.0.21. It means I'm going to terminal A. I put admin password and I'm logged to the system. This is the basic page. You see some additional data like link name, terminal name. This is not by default, they are empty. You see air data rate. In this case it's 700 megabit system, and you see the regulatory. This unit it's not for FCC, which is North America and Canada country or area. It can be used in Europe and other countries, only not in this FCC, which is USA and Canada. System status, it's providing whether radio interface is up and whether Ethernet port it's up. In this case, it's because I'm connected directly to this one. For testing, first one, what I think it's important is that you put the IP address which you are using, for example, in your company network. In my home network, I am using 172.31/16, and what I did, I changed the IP addresses to this one. 2122, admin password, it's same. And also important is if you are doing mainly test on the lab or in lab, to check what is the radio level or radio configuration, whether you have same frequency pair on terminal A and terminal B, and whether the receiving level is okay. Okay, we are a little bit out of time. I cannot go so much to the live session, but I screen this picture. I make screenshot of web GUI. You see I was connected to the default V1000 system. These are default addresses. I programmed the new addresses, and then you see using the new address, going to the radio parameters, I check that okay, I am using frequency 59.5/62 and medium power control. Okay. This is about configuration. It's very easy. It's on this slide. Just configure addresses and check the radio parameters. Now, if you need to test in the lab, what are key points or how to verify that your network or link setup it's okay. This is from a document which is called bench test setup. There are key points which you have to follow to be sure that your setup will really work. Yeah. First one, if you are testing in the lab, our recommendation is to use one source of electricity to avoid mistakes or some damages or issues that you are connected to different lines, because in some buildings you can see big difference between line 1, 2 or line 1, line 3, and this is good to use just one power outlet. Then use cable going to the PoE. You can connect computer to this PoE and some cable. We know that for some configuration, especially if you put PoE to the switch, it can be issue with cable. You know that we have 1 meter cable which is going from the terminal. Then you can use seal kit, and it's good to put some long cable, 3, 5 or 10 meters between PoE and terminal. In this case, you know that there is no issue with short cable. Also, it's recommended to use the grounding here. And same on the opposite side. and connect another computer. This is really basic picture. Important is, you see, if you are doing some distance, there are some distances which are typical, but you can simulate some attenuation to make this distance shorter. You don't need to set up the link to the 100 meters. But if your link is really 100 meters and there is no ATPC on V100 systems, our recommendation is set to low. If it's between 100 and 200, set it to the medium and then to the high. On V1000 and E1000, it's okay because now we have ATPC and you can activate ATPC. Without ATPC, you have to check what is the recommended level power. Everything is in user documentation. You can easily find it here. And okay, now if I am doing lab testing to be sure that the system is up and running and there is no issue with wireless part, I am doing in this setup. I have computer going to the PoE to the one unit. This unit is configured to this address 1021, and opposite unit is just connected to the PoE and it's using 1022. On PC, I am concurrently opening 3 windows. First one, it's web interface to the 21, which is okay because I can open it as I am logged or connected directly to it. And you see, I am going to the home operation system status, wireless status. And in wireless status, I am setting the refresh interval to 3 seconds. Because if link is up, if link is not up, you see just the some value in min, mean, max, and current. Because these values are read from this 21 device. If radio link is up and user data are passing through, you will also see information from the remote node because the units are exchanging what is the receiver level of the opposite side. If you have this configuration that you see some receiving signal, because I see like minus 44.9, but nothing from remote, it means I'm receiving some radio signal, but it's bad. It can be even some, modify or some reflection, and I have to check, wait till I have something from the remote. And to be sure that link is up, it's very easy that you run additional 2 commands. Ping for local. I see this is this white one. I am pinging 21, which is this one. And second one, which is green or black-green, it's pinging to the opposite side. My screenshots are from Linux-based machine, or it's Mac machine, which is pinging every second 1 frame. If you are on Windows, my suggestion is use the option -W space 1 space -D and then IP address. This command, it's not waiting, and every second it's pinging, because normally Windows are pinging and wait 5 seconds for the response, which is usually too long time if you are doing some testing. This is very useful that you are minimizing waiting for 1 second and you can play with the link. And wireless link now in this case was, as you see here, it was just 2 terminals close together. This is usually issue because link is not up, and you have to check a couple of points. First one, on V-band especially, it can be wrong polarization. Second reason can be too strong RX signal. And last can be terminals are not aligned. They are a little bit out of axis. They are not, how to say, 100% symmetric. Solution for first one, polarization. You have the arrows on the back part of the terminal, and you can check whether they are both in same orientation. If you have too strong signal, you have to use some attenuation. You can either use the RAM, which is radiation absorption material, which is like foam, which is making some attenuation. But as temporary solution, you can also take the paper pack, this pack of papers for printers, which is in additional pack. You have 500 sheets packed together, and you can put it between terminals, and it is doing attenuation. And if still link is not up, play a little bit with the movement of the terminals. And this is example about this polarization. If you are looking for the V terminals, the terminal A and terminal B, they have this Ethernet port in different position. And it means if you are doing testing on the lab, and if you put terminals and you don't have this Ethernet port on same side, you have like this one that you have left and right, this one. This is good because the polarization is okay. If you have this scenario, like you have here and here, it's definitely bad because one will be in vertical and another will be in horizontal polarization. This is first one. Check polarization, very easy. from the back part you can see arrows, and they have to be in same orientation. It can be either down up or left right. The second, use some attenuators. For V-band, as I mentioned, you can use this RAM, which is foam, which is doing some attenuation, or you can use this pack of the papers for the printer. And last one, if you have everything and think it's still not okay, move a little bit with terminals and check the application, web GUI and pings. After it, if everything is proper, you see now that I have now local signal, I have some remote signal, and I have also ping to both terminals. If you have such scenario, in this case, the terminals are in proper orientation, proper polarization, and you have also enough attenuation. And you can see here now we have two parameters which are presenting what is the quality of the signal. First one is receiving level. It's okay, we just measure what is the level of the receiving signal. Second one is vector errors. And vector error is saying how bad is receiving signal compared to ideal position. I will not explain so much in theory, but what is reality? If you have some, generally it's in documentation, but again, I know how we are reading documentation. But if it's value -10 or lower, like in this case -17, -18, it means we are receiving good signal. We are able to detect what symbols are sending. If you have something like -5, it's a situation when you are receiving some signal, but the system is not able to decoding the data or radio symbols from this one. And this is what you can, if I will go back to this first page. Oh, it was minus, okay, in this case it was looking not so bad, but typically you can see, for example, something like -4, -5. If you have links or terminals and they are not oriented properly, that they are somehow disaligned, and this is what you have to check. You have to have good receiving level of the signal. In this case it's okay, I have -50, and you have to also have vector error -10 or lower. -10 is something like edge between good and bad. If you have -5, it's definitely bad. If you have -13, 14, -18, it's definitely good one. And if you have this setup, you can run testing, mainly the configuration. But keep in mind, this is something like artificial link, and if you are going to run RFC test, you will probably not be able to find the best result. The reason is because this link is still, you know, somehow, or signal is somehow affected, and you have to keep in mind this is mainly to verify the configuration. You can make some test for the throughput, but there is high probability that you will not achieve the regular, or you will not pass RFC tests, because again, the error rates on such link will be much higher than on real link. For E-band, it's because I have live system, but there will be no time to check it so much, I just use the different addresses. On V-band system, it's easy because we have integrated antenna and we can just put antennas and some attenuator between. On E-band, it's different because you have external 30 or 70 centimeters antennas, which are dishes, and they are producing a high power signal, much higher power signal than integrated antenna. And it's not so easy to align or system with antenna on the table, but there is still some temporary solution which is called some attenuator again, or some attenuator kit, which is able to provide you testing. In this case, it's looking like this one. You see, do not use antenna in lab. It's no way how to work with antenna in the lab. You can do it just for photos and so on. But if you need to test the link in the lab on the table, you can do it in this way. You see, I have terminal. In this case, this is terminal A, this is terminal B. Polarization here, it's usually not issue because you have, you know, this is like asymmetric plate, and you are usually putting the plate in same polarization. But anyway, you can still check the arrows on the back. But if it's like this, that you have this extension on this one, or on the opposite, you are on same polarization. And units are connected through some small plastic tube, and inside this tube there is again the attenuation foam. What is good that our product team is working on such tool, and I know that Malcolm has already some this tool, and it's just up to, if you see useful to have such tool, you can simply ask, and Sub10 will provide you what is the price. I hope it will be not so expensive, and you can use it. You can use it on our system. If you are out of time and you cannot wait to have such tool ready, you can use my home solution. You can find the plastic tube which is okay for this how to say diameter, internal diameter. It's same as outside diameter of this waveguide, and then put some RAM inside, and then put unit together, and it will work as well. And again, same as before, you have to play with the orientation of the terminal. When you do everything properly, you see I am pinging. It's same scenario. Computer, but I am pinging default address is 021, 022, and you see on 22 I see the perfect receiving level and good vector error. And you see now the lowest on E system was minus 3.8, because when I put system together, I was totally how to say rotate signal, and this is why you see so low or so high or bad vector errors. This is minus 3.8 means it's totally bad signal, or we are not able to restore the radial symbols from such signal. Okay, this is about testing on the lab or in the lab. Keep in mind you have to check whether radio parameters, vector errors, it's okay, and the best way is to use the ping to the opposite side when you are doing this movement, and you have to always wait some time, like move a little bit, wait 5 seconds if ping is up or not. Terminal installation. Before terminal installation, please check documentation, because there is a lot of useful information, and there are also very nice schemes or pictures how to make proper installation. What we found on our installation or on installation which we visited, definitely use the proper cable type. It has to be at least Cat5e, and it has to be outdoor version. The next point, the grounding. Really think how it's grounded and verify that it's grounded to avoid any you know, the potential floating between the grounds, wires and lines. Do not remove change RJ cable on terminal. I didn't mention it here, but you can see now from the terminal the Ethernet cable is going this one, and there is additional protection which is fixing, and this connection it's really tested to be waterproof. On new system you have here label, if you are taking out, you are avoiding warranty, some warning to be sure, but remember, do not remove it, because otherwise you are making easy way how water can go inside the terminal. And if there is small water going in, the first one is going to the RJ45 connector, where is also power going in, and you will have, you know, some water going on power which is plus 53 volt DC, and the copper on these connectors will be destroyed very soon, and your system will be not functional. Cable length, remember 100 meters, it's from terminal to switch or PC. You cannot count it just to the PoE, because PoE it's passive device, it's not gigabit Ethernet, and you have to count cable between PoE and terminal, and between PoE to some switch or router, and these two cables cannot be longer than 100 meters. And again, very often proper size of mast or diameter of the mast. If you look for 60 centimeters antenna, and if there is normal weight, which is, I don't know, 20 meters per second, and you put it on the 40 millimeter pole, it will definitely not be good, because there will be big vibration of the mast, and there is high probability that your link will be disconnected or drop down. Very quickly, pictures from our installation document. V100, V100, V1000, it's easy because you have terminals, you have this bracket which is mounted directly to the terminal. If you need to mount it on the wall, you can directly mount it on the wall, or you can order this plate. If you are doing installation on the mast, which is the most typical, you are adding to this bracket additional piece which is also coming with inside the box, and then 2 metal strips, and you are fixing it on the mast. It's very easy for installation. Alignment is very easy for V-band, because you have this two, how to say, snail screws which are moving left, right, up, down as you need, and it's very easy for alignment. On E-band, you have to be a little bit more, you have to do a little bit more. First, you have to install antenna. Keep in mind, antenna it's going partially assembled only. You have to put some pieces together to minimize the size of the pack. And in each antenna, there is 4 pages document how to do it step by step, including how washers are organizing and so on. If you are really looking to the paper, you cannot do it wrongly. Just follow the pictures on the paper. When you install antenna, you have the protective cap on the antenna and also on the terminal. It's logical you have to remove it, attach the terminal and check the polarization. And again, do not make proper grounding. This is good installation. You have antenna, terminal on it. You see, based on the polarization, it's a vertical polarization. And you have here one screw using for grounding, and it's grounding to the mast. And then you have Ethernet cable going to the seal kit. If you install just antenna, it's looking like this one. You have 30 centimeters antenna. On this is waveguide to radiator, or this is end of the radiator. It's normally protected by cap. Take this plastic cap, and my suggestion is do not throw these caps to some garbage. Hold it, because later on if you need to do some manipulation, it's always good to have this plastic cap to make protection. The reason is this is waveguide. This small hole in the middle is waveguide, and if some dirt will go in, or even water, it will definitely affect the quality of the signal. 60 centimeters antenna, very similar, just a bigger antenna. And one remark for the E-band, if you look here, there is the label Sub10, and this is right orientation. If you look for this one, there is something which you can read normally. And if you look for the bottom, there is the hole which is allowing water which is condensated inside going out. And same for this one. 60 centimeters antennas, you see there are 2 holes, but they are using the gum protection, and they are open on the bottom. And again, this white label, this label with Sub10 has to be on the upper position. There is a question coming about, I think, about okay, but there was a good question. On the paper you have some lubricant which is coming, and the lubricant is good to put on this antenna. You see there is the gum O-ring or gum ring which is doing again some protection for the water, and it's good to put this lubricant around this ring to be sure that water is really not able going to in. And same if you look for the screws which are here, they are metal and they are going to the aluminum type of pieces. It's good to use some lubricant on this one, because later on if you need to open it, it's time to time not so easy. If you have metal and aluminum going together, they can make very fixed connection. But the question is, yes, inside of antenna you have lubricant, and use this lubricant for this protection, that you will put it around this gum O-ring to make again more waterproof connection. Okay, lightning protection. It's again from documentation. If you have, there is also describing how to calculate what is the risk zone for your installation. What you can do if you are deploying link in high risk area, to use the LPU. It's very easy. LPU will be installed close to the ODU. In this case, you don't need to use seal kit, because cable, 1 meter cable from the ODU will go directly to the LPU, and your cable going to the server room will be connected on the second port. And you see ODU is grounding to the LPU, and LPU is grounded to the mast or building ground. If you need protection also before cable is going in, which it's also useful if you are connecting some expensive switch or router, it's a similar situation that you have LPU. This LPU is grounding to the building ground or connected to the building ground, and then cable from the mast is going to one port, and second port is going to the PoE, and then you are going to the data. Link alignment, we are almost out of the time. Very quickly, V-band, for coarse alignment, use optical scope. It's very easy. You will point it what is the opposite end. For 30 centimeter antenna on V-band, you can use scope. This is exactly this configuration. You see it's vertical polarization, and you can put scope on this corner, and you will see on the opposite side. For 60 centimeter antenna, we are working on tool which will be usable for this one. With scope, you will be able to see opposite side to be sure that you are on the right orientation or right direction, and you will probably receive some signal. And last, it's use final alignment and use DC voltmeter. Each terminal has DC port, which is this one. It's QMA connector, and with system you are receiving this cable, which is QMA connector and 2 banana connectors. You are able to put it to the voltmeter, and you see in this case it's 2.52 DC voltage, and you can compare it what is the receiving level. Now you see, you have picture. I hope that it will be visible through the scope. You see here there is small white dot. This is opposite end. I'm just now pointing a mouse here, and then you can simply align antenna to go close. Now we are on this. This is exactly the situation that we are pointing to this opposite side by scope, and then we are achieving almost the highest power level. For fine alignment, it's normal that you are going left, right, and slowly up, down, or vice versa, left, right, and going down. Important is that you are doing this alignment just on one side. If you are doing this final alignment or any alignment, you are just moving one unit, and opposite unit it's fixed or not moving. When you finish and you are on the best signal, you have to do it from the opposite side again. Look for the best signal. And normally you have to do this, how to say, approximation more times. It's not so normal that you will after 2 alignments be on the best signal, but 3, 4, 5 rounds and you are able to achieve expected signal. Okay, typical mistakes. I will start with I think the one of the most mistakes. It's called near field obstruction. Again, in documentations for V and E band we have pictures or scheme what has to be minimum distance for some obstacles near to your terminal. And this is example for this installation. You see they have nice roof and they install the terminal something like 3 meters far from the roof. The solution is, of course, and customer reported some problem with stability. The solution is put the mast to the edge of the roof to avoid situation that you have something here. The next one, it's again similar. It's looking like okay because we are close to the roof, but keep in mind we are close to the roof, but we are shooting over a roof which is additional 100 meters. If you look from the Google map, this is the position of the terminals, and we are shooting over this long roof. Again, if there will be water, it's like mirror. There will be a lot of reflection which can affect your systems. Second, the example number 3, it's again looking good. It's on the back side of the building, but if you go up, you see again same scenario. There is mast, and there is 1 meter, and then if you look, it's like 30 centimeters, and we have this roof here, which is definitely metal. And again, if you look, it's affecting Fresnel zone a lot. And these are pictures from our documentation. If you look for V band, you have this diagram what has to be clear on the near end, and you have also diagram how to check. And this is, if you look, you have to be something like, I don't know, better it's to use at least 1 meter, and 5 meter, nothing between radio and free space. For E-band, it's very similar. You have again 1 meter. This is why I'm saying, remember, 1 meter and 5 meter long. There is to be no obstacles, and if you are installing on the roof, just double check that there is nothing in this, how to say, orange or red area. Next one, sometimes think it's not working. It's happened time to time as well. You see this one, it's chimney, but it's not chimney for heating. It's chimney from air condition from kitchen, and you see normally there is some steam or like hot air, including some, you know, some disty parts. And it's really important if you are installing link and you are here like 1 meter. This is normal situation, but if they are, for example, preparing some steak or hamburgers, there is much bigger steam, going, and it's really hot air which is affecting your signal. And in this case, you will probably detect issue on the link, that link is dropping time to time. If you look for the time, you will probably see that it's just before lunch or dinner preparation. Yeah. This is again bad installation, because you are this chimney is producing hot and very wet airflow, which is going close to the unit. Line of sight, just some examples. It's looking like nice, because we are going close the link. It's going this one. It's looking okay. It's not so problematic. If you are on opposite side, it's maybe look good as well. But if you put some rings here, you see, okay, maybe this building is not problem, but this tree, it's definitely problem. This is in December time frame, but during the how to say, from spring to autumn, when there are leaves and it's raining, it is affecting. But definitely after a couple of years, these trees, the branches of this tree will be much bigger, and it will be definitely affecting Fresnel zone here. And same here, again, it's looking like everything is okay, but if you look in details, you see that there is a lot of branches which can go, and which can, especially if it's windy, this is not so stable tree, and it can affect your Fresnel zone, that it can go through the wind to this one. And also mast stability, in this case, you see it's this mast was by hand. It can move 10 centimeters without any issue, and it can affect your link stability. Next, I mentioned proper cable. This is also from real installation. You see the indoor cable are going to the seal kit, and there are two issues. This PVC jacket, it's not designed to be long time affecting by UV radiation, and also the mechanically it's not so stable. And it happened at this customer that very soon, when cable is when cable is going in, you can see damage on the PVC jacket, and very quickly it can affect it also wires. And it was happening at this customer that link was working, but port was not able to go to the gigabit Ethernet, just fast Ethernet. And it was obvious that for gigabit Ethernet, all 8 wires have to be okay. For fast Ethernet, just 4 wires are enough. And it was exactly the case that the brown wire was affected, and it was making a loop between the ground and this wire. Next example is good. It's not mistake. You see it's proper grounding, that it's grounded to the mast, and mast is grounding to the building ground. And this is the highly recommended to make it like this one. The terminal going to the ground point on your mast, and mast has to be grounded to some grounding point on the roof or on grounding building. Next one, its issue is installation, which is not related to our product, but it's typical. Take care about the cable management and power supply management, because you see here a lot of stuff just on some foams on the roof, on the floor, cable going up. You see they are really short one, and anybody who will touch this device, which is power supply, will definitely affect the link quality, because link will go down. And same here, if you need to disconnect any cable, you will probably disconnect more than one. And the final picture, it was funny that there is normal how to say, power outlet, and for critical they simply put a red label, do not remove. Yeah? But if there will be somebody who is not so good, he will check, hey, why do not remove exactly this one, and it will be first one which will be disconnected, I think, in case of the troubles. Okay, time for questions. It's I don't see any question. Okay, do you have any question? If yes, okay, I see. Okay, after this, there is generic. I receive a lot of emails. What I will do, I will put on our support. Okay. The main question was regarding these materials. We will share these materials, and this session is also recorded. If you need to go to this session later on, it will be possible. You will receive a link for this recorded session in the email, and also for the slides. Before this leave, just really last 2-3 slides about the resource or information sources. We have a regular Sub10 system web page, which is, as you expect, or server, which is www.sub10system.com. But for you, as for technical, it's more important that we are running a separate server, which is support.sub10systems.com. And this server, it's, how to say, more up to date, because we are able to do changes by us very quickly. And important for you, as for technical users, is that you can create username and password, which is okay. You can just register, and we will manually approve this registration when you confirm that it's really our partner or our technical partner. And after it, you are able to go to full Sub10 system support server. And important is that all new firmwares are published on this support server. But to be able to download it, you have to have login. Keep in mind, create login. We will approve this login, and later on you can download new firmware, and you can also find some older firmwares. We are not doing something like protection or some hiddening of the firmwares. Everything is available, just you have to have the login or username activated on this support web. The next sources for, and I couple of videos, it's really helpful, it's on YouTube. You can, for example, look for this YouTube alignment, E1000E alignment. I didn't mention it exactly because it's not detailed installation course. Just you can go here and you see 2 minute 45 seconds video, which is providing you basic, how to say, basic basic instruction how sensitive it's E system for alignment. And on the video, you can on the YouTube, you can also find more. You can, for example, see how seal kit is installed properly, how you can add additional protection for the seal kit. If you are using cable with some catenary cable, that you have some chain in the cable for if it's self, you know, how to say, going between two masts and holding on this metal part, what you have to do on this. It's very useful. Another video is how to make the reset on the terminals and so on. Simply go to the YouTube and search for Sub10 systems. And I will check. Okay. And there is about adaptive code modulation on V1000. I mentioned it will go very soon. If I'm right, we expect that it will be available on load, which will be published this week. I hope that Malcolm is still here. Malcolm, can you confirm? I will just check. Okay, adaptive code modulation will be available soon. The plan is to have it in some tested firmwares this week or the next week, the latest. Okay, if there is no more question, I would like to thank you for your time. Again, a lot of question was related to these materials. The session is recorded. You will receive the link where it's stored, and we will also put the slides without. There will be like two files. One will be recorded session that you can go and you will see screens, and also the speech which was related to this screen. It will be one link, and second link will be just the slides, which will be not so big one. Because the recorded audio, it's usually more than 100 megs, but the second file will be just the slides for your usage. Okay, if there is no more question, again, thanks for your time. And if there will be any question, you can contact me, or you can use the support web page, when you can also put any question, any comment. Okay, guys. Thanks a lot. Have a nice day. Bye-bye.